Have you ever wondered what could wipe out 96% of all life on Earth? Not with a bang like an asteroid, but with a slow, insidious poison seeping into every corner of the planet? Welcome to the Arsenic Apocalypse, the overlooked killer behind the greatest mass extinction in history. This isn't the dinosaur-ending Chicxulub impact that steals the spotlight. No, this is the Permian-Triassic event, or the Great Dying, 252 million years ago. And at its heart, arsenic, a silent toxin that turned paradise into a graveyard. Buckle up as we dive into this forgotten catastrophe, backed by geology, paleontology, and a dash of modern science. Let's set the stage. Earth has endured at least 5 major mass extinctions, each reshaping life as we know it. The Ordovician-Silurian wiped out 85% of marine species around 445 million years ago. The Devonian lost 75% about 375 million years back. Then the Triassic-Jurassic, 201 million years ago, cleared the way for dinosaurs. The Cretaceous-Paleogene, 66 million years ago, ended the dinos. But none compared to the Permian-Triassic. It erased over 90% of marine species and 70% of terrestrial vertebrates. Forests vanished, oceans emptied, and survivors clawed through a barren world. For years, scientists pinned it on massive volcanism from the Siberian traps, a flood of lava covering millions of square kilometers, spewing carbon dioxide that superheated the planet by up to 10 degrees Celsius. That warming triggered ocean acidification, anoxia, dead zones starved of oxygen, and hypercapnia or CO2 poisoning. But there's a darker layer. Toxic metals unleashed in the chaos, with arsenic leading the charge. Arsenic isn't some sci-fi villain. It's element 33 on the periodic table, abundant in Earth's crust at about 2 parts per million. In low doses, it's even essential for some microbes, aiding metabolism. But crank it up, and it's a cellular assassin. Arsenic mimics phosphate, slipping into DNA and proteins, shredding genetic material and halting energy production. It causes mutations, organ failure, and death, slowly, by disrupting food chains from plankton to predators. In humans today, chronic exposure leads to skin lesions, cancers, and neurological damage, as seen in Bangladesh's groundwater crisis affecting millions. Now imagine that on a global scale during the late Permian. The trigger? The Siberian traps didn't just erupt lava, they fractured ancient sediments rich in arsenic-bearing minerals like realgar, orpiment, and arsenoporite. As magma intruded and lava flowed, it heated and mobilized these deposits, volatilizing arsenic into the atmosphere and leaching it into rivers and seas. Studies from the 2000s, including work by geochemist Andrew Mayharg in his book Venomous Earth, argue this created a mass poisoning event. Sedimentary rocks from the Meishan section in China, the global stratotype for the Permian-Triassic boundary, show spikes in arsenic concentrations up to 10 times normal levels. Isotope analysis reveals volcanic sourcing, with arsenic aerosols raining down, contaminating soils and waters. In the oceans, it was apocalypse now. Pre-extinction seas teemed with trilobites, ammonites, and bizarre fusulinid forams, giant single-celled protists building reefs. Warming expanded ocean stratification, reducing circulation and oxygen. Anoxic bottoms released more arsenic from sediments, where it had been bound under oxidizing conditions. Suddenly, toxic plumes spread, poisoning filter feeders first. Plankton died en masse, collapsing the base of the food web. Larger creatures like the iconic gorgonopsid reptiles on land suffered too. Fossil evidence from South Africa's Karoo Basin shows malformed bones and teeth in survivors, hinting at arsenic-induced developmental issues. One study in 2015 from the USGS examined mutant fossils from the Ordovician extinction, a similar event, and found elevated arsenic, lead, and iron causing deformities in ancient sea life. The pattern repeats: volcanism plus warming equals metal mobilization. Why did this arsenic apocalypse fly under the radar? Popular narratives love drama, asteroids, supervolcanoes, but toxins like arsenic are sneaky. They're not flashy. They accumulate subtly over millennia. Early extinction models focused on CO2 and sulfur, but geochemical sampling has only recently caught up. A 2018 paper in Philosophical Transactions of the Royal Society reviewed killing mechanisms for the Permian event, noting hypertoxic metals as amplifiers of anoxia. And it's not just Permian. Mayharg's research links arsenic surges to multiple extinctions. During the Great Oxidation Event 2.4 billion years ago, rising oxygen oxidized arsenic from insoluble forms to soluble ones, poisoning early microbes until they evolved resistance, locking it away in biominerals. Fast forward to the Ediacaran 550 million years ago. A 2022 PNAS study ties the first animal extinction to environmental shifts, including trace metals like arsenic stressing soft-bodied weirdos like Dickinsonia. Even the dinosaur killer might have an arsenic twist. The Deccan Trap's volcanism predating Chicxulub released toxins, weakening ecosystems before the impact. A 2025 YouTube analysis by Science Channels highlights arsenic's thread through all 5 big extinctions, from volcanic sourcing to oceanic release. It's a recurring villain exacerbated by Earth's restless geology. So what does this mean for us? We're in the midst of the 6th extinction, driven by habitat loss, pollution, and climate change. Arsenic lurks in our story too. Mining runoff, coal ash, and rice paddies concentrated, poisoning 200 million people globally per WHO estimates. The Permian warns us, ignore slow toxins at your peril. As oceans warm and acidify, anoxic zones expand, potentially mobilizing seabed arsenic like never before. Coral bleaching today echoes ancient reef collapses. The arsenic apocalypse teaches resilience. Life rebounded after the Great Dying, birthing dinosaurs, mammals, and us. But survival demands awareness. By studying these geochemical ghosts, we arm ourselves against repeating history. Next time you hear about mass extinctions, remember, it wasn't just fire and brimstone. It was poison in the veins of the world. Thanks for joining this deep dive. Subscribe for more hidden chapters of Earth's wild past. What extinction mystery should we tackle next?